I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast.
Hey, Ben.
Hey, Matt.
I can't believe we're laughing already. Ben, very, very, I don't know what the right word would be, but like you bent
auspiciously?
Auspiciously. That's not the right word, but you took your microphone and kind of bent it out of the way so we could have a nice talk. And your headset microphone wasn't the right way, isn't in the way. Oh gosh, it's too early in the week to be recording a podcast, and yet here we are.
You mean Friday? It's
yeah, I guess. Oh no! Now everyone knows.
There's not a lot of time left, my man.
That's true. Somehow we're in May as well, which this podcast will go out in May as well because it has to.
Yeah, right.
Otherwise, we're in trouble. We not got any in the bank. Yeah. So what are we talking about today, Ben?
I thought we could do at least one podcast, and maybe we'll do this again on kind of like how computers actually work. And
I love it.
I think a way in which to cover the extremely broad topic of how computers actually work is to look at some of the maybe non-intuitive behaviors that they have.
Okay.
Things that, people kind of take for granted as sort of like an abstraction that you rely on. And, peel back the covers a little bit and explore how it works. And maybe even, if we get to it, some like non-obvious ways in which it breaks, right?
Oh.
And like when it doesn't work, what is actually happening? Because I think that sort of understanding the failure modes of these things is a great way to understand what's actually going on. So
for certain,
that's my general idea.
Okay, so we've got like this sort of general idea of the theme of how computers really work, which obviously is very close to my heart as well. So this sounds brilliant. And then we were discussing some things before we started, and shooting around ideas. And I sort of suggested there used to be like an old Google interview question, which was what happens. You type google.com into a browser, you hit enter, what happens? And I always like that because there's almost any number of ways that you can go. But how about we simplify that a bit? What happens if I have curl rather than a whole web browser there, and I curl some simple URL, right? Not JavaScript or anything. Well, I guess it doesn't matter, but
I mean, it could be JavaScript. A document. I guess so. You're fetching a document.
It doesn't
curl.
even matter at that point because it'll just print it out in front of you. Yeah. So should we try something like that? What happens if we curl google.com? In fact, I did this only earlier today as I was playing around with sandboxing, and I curled exactly HTTPS google.com, and I know exactly what it returns.
Can I offer a guess before you tell me the answer?
Offer away.
Yes. Does it give you a redirect? Something in the HTTP 300 range would be my guess.
It does. It tells me the document has moved, and it tells me the document has moved to www.google.com. Which was like, oh, really? Yeah, I guess, because I was very lazy.
Yeah. So how does it tell you that?
Well, in this instance, the curl told me just a document. It printed out a document in front of me that said 300 or whatever it was, document moved, and then it had a tiny little bit of HTML that came to me because I didn't have -d- or whatever the thing is to print out all the headers and stuff like that. But
okay, so you didn't see. So this was going to be my question. Is my understanding of this is whenever you request a document over HTTP or HTTPS, you're getting two things back. You're getting the headers. And you're getting the document body, right? And so when it was redirecting you, all you were seeing there was the document body, which was some HTML. Is that correct?
A very small piece of HTML, which you would normally never see. No browser would render that, really. Because the real need of it was in the headers, right?
Yeah. Okay. So then when you do that, and I'm just kind of going through, I'm trying to like answer the interview question here a little bit.
That's right. Yeah.
So when or maybe I'm interviewing you. I don't know
which way around this is anymore because I thought it was going to go the other way, and now we've seemed to have flipped it. Yeah. So carry on.
I don't know who's. I mean, it's a collaboration.
What even job is this?
Here. I know.
What are the benefits?
We don't have jobs anymore. They're all taken by robots.
Oh yeah, that's true.
So when you make this request, you're going to get back headers and you're going to get back the body. like how is the request delivered and how exactly is the body returned? Like what protocol is it using to do that?
Right. Well, I mean, I know that the particular command I was using is absolutely HTTP/1.1.
Mm-hmm.
And I mean, this is one of those cool things. I know that maybe this is showing our age a little bit, or certainly my age. I think I've got a few years on you. But at university in the late 90s, in the mid 90s, darn, learning that you could telnet to a port on a machine and just type stuff in and get them to do things. So like, the most happy day was to discover how to send emails from other people. I don't recommend that folks try this anymore. I don't think it works anymore, but you used to be able to telnet to the mail port and give it just raw commands. And it would be like very trustingly say, sure, that you're at god@universe.com. Fine.
Right.
Send your emails, please. Right. So you kind of got this idea that everything was like this text-based thing. And I remember this early web thing, and this was HTTP 1. So you would just literally telnet to port 80 of some machine and type get space / and hit enter. And then you get the document back. No headers, no nothing. It was just, that was the whole thing. But nowadays, HTTP 1.1, we have to tell it more information. So you are going to connect to a TCP port on the machine, usually port 80. 443 nowadays. Everything's HTTPS. So
for the
purposes of talking about the protocol, at least this level of the protocol, HTTP, let's ignore SSL for now. Let's see if we can get to it in time. But
like Tom Seven in his most recent video.
Correct. And I'm so sorry. This is my family coming home in the background, and we thought we'd beat them, but no. So my dog is announcing their arrival. Much as you announce your arrival at the HTTP server by asking it. Whoa, segue there.
Meta.
So get, it's still a verb like get or put or post, and most of these things would be like get. Then the URL, or rather the document locator on that machine itself, and I forget the exact terminology for it, but that's the bit after the host name, but before the hash, if there's one in your URL. So like in Google, it will probably just be // if it was your Google, because that's the only thing you've got. If you're going to google.com, then you put a space and then you tell it that it's HTTP/1.1, which tells it, hey, I'm talking to you in the new way, new way. I mean, there's quick and there's HTTP 2 and there's other things, but like for simplicity, let's stick with this. Then you're expected to send a bunch of headers. Each header is a bunch of ASCII bytes followed by a colon, followed by a space, I think. Maybe the space is optional. And then some other stuff in the new line.
Yeah.
So it's pretty human readable as these things go. And the one thing that you will be most required, I don't know if it can be more or less required.
The utmost requirement.
The highest requirement is to put host : and say actually what host, again, my dog in the background, you'll have to apologize, but what host I'm actually requesting from, because this was like the big unlocker, I think, in like the early aughts, whenever this thing came out, which allowed you to have more than one website per IP address.
Right.
Because if you just do get / you're like, well, which website did you want? I don't know, right? It's whatever. But that was the way to solve it. Maybe it would have made more sense to do get HTTP : blah and just give it the whole URL and say, you work it out. But
maybe.
Anyway. But host : google.com is what we would have said. And then, I mean, from my own personal experience of telnetting to google.com to see how it works, I know that all you need to do to get it to work at all is to do get / HTTP 1.1, host : google.com, return, and then a blank line that says, I'm done with the headers now. And then you get the document that says, no, surely you meant www.google.com. You're like,
right.
Nevertheless, connectivity is there. And then it will close the connection, I believe. So that's what I think would happen in I'm doing it manually myself with Netcat or Telnet or something of that nature. What am I missing? What's next?
No, that's good. And I mean, I love doing that exercise when kind of explaining HTTP to people because it takes the magic out of it. Now you introduce a whole lot more magic when you add in like TLS and a bunch of WebSockets and other things like that.
A fantastic quote by one of our friends. It was to do with optimization as it happens, but you mentioned magic, and I wanted to sort of like bend it to this, which is that he said, like HTTP is like magic, and you're like, well, it isn't. It's just like a bunch of like ASCII being sent over.
It's just text.
Yeah, and then words. And that is like magic, because if you actually show people how it's done, it's kind of disappointing afterwards. You're like, oh, it's just, I see. Yeah, there's just two of them.
Like, oh yeah, the rabbit was already in the hat. It was there the whole time. It was there the whole time. It's not special. It's not a special hat. It's not a special rabbit. It's just the rabbit was in there the whole time.
It was there the whole time. Exactly. But I love that feeling of like magic is that. That's what magic means, really.
Yeah,
it's disappointing when you know how it's done, actually.
Right.
But anyway, not disappointing, because now you know how it's done. You can go, oh, cool. This is something I can build on, and I understand, and I can debug, and so on. But this is obviously is not curl. This is just me doing it manually and you doing it manually.
Right. So when curl is doing this, in the base case, when it just works as expected, it is
not that kind of base.
It is opening a TCP connection to whatever IP address was resolved from the host name that you gave it.
Yes.
It is sending that initial request with the HTTP verb, as it's sometimes called, the get, the post, the put, whatever it is. It's sending all the headers that it might send, and curl sends a lot of headers on your behalf, right? You can tell it to send specific headers, but you can also not. I just want this document, please, and it will add in whatever headers it thinks are appropriate, including a user agent.
Agent, yeah. Hey, I'm curl this version, and stuff like that. And what type of documents it'll accept, I think, is a list of things. And then potentially something to do with the connection in terms of closing the connection or keeping the connection open for further requests, which,
one of the side note here, one of the interesting ways that you can detect which client is actually connecting to you, because, the user agent is supposed to say, but obviously that's like kind of voluntary. You can put whatever you want in there. But one of the interesting things that you can do is you can look at the order of the headers, because the order of the headers is not specified in the protocol. So it can be whatever you want it to be.
But it's a fingerprint for the client code that connected.
Certain clients tend to put the headers in certain orders, and depending on what client you're using, that can be an indication of what it actually is.
Oh my, that's sneaky.
Yes.
Ben, you are a sneaky man. What is the sort of like fingerprinting based on the fact that curl always sends them in this order, and Chrome's fetcher does this, and Firefox does this. So it doesn't matter how you configure it. It's to say like user agent liar. It's like, but we know you're Chrome, really.
Yeah. Similarly with like as you said, like spaces in between the headers and the values. Right. Optional. You can do it either way, and that creates also the casing on the values is another thing that can create sort of a fingerprint here. So curl is choosing to do it the way that curl does it, and even if you change the user agent to be like, oh no, actually I'm Firefox, it's possible that somebody else might be able to figure that out. But the header order is not actually really, and I might be lying here, but I think it is specifically not important. Like the order,
I think it is unspecified which sequence they're
unspecified.
In. Yeah, I think so. But dear reader, listener, sorry, not reader. Gosh, listener. Again, it's been a week. Check what we're saying here. But this is just two old farts comparing notes on what they remember about how this works.
Right, and as you were saying before, oftentimes web servers are very tolerant of any kind of sort of garbage they may receive. And I think you said that you literally were just doing get / on Google earlier today with no protocol.
No, this one had no, this one did have get / no, this was still using curl. I didn't actually turn it today, but like I think nowadays if you do get / it will tell you to go away, because that's HTTP 0.9 or whatever the one that didn't even have the version.
The unversioned version. Yeah, right.
Yeah, something like that.
So those headers, you're sending those headers whether curl is doing it for you or not. You can obviously be explicit about it, but if you don't do anything, it'll do it for you. And then depending on the type of verb you choose, the request itself may also have a body.
Oh, yes, that's a good point.
And this is particularly important for put and post.
And patch, I think, is another one I'm thinking of.
Probably patch, but you can also do it with get.
Oh,
I'm pretty sure that you can include a request.
So one of the header fields is content length. Is that right? Is that the thing that gates this? And then you tell it how much you're going to be sending it or receiving. Certainly the response has a content length that says, this is how long it's going to be, or it can be. But if you're going to do anything that requires you uploading, you need to tell it where the end of your thing is, your data. Right.
Which is why, by the way, it is particularly difficult, if not impossible, to stream the body of a request. Like if you have some input stream that you're reading from and you're like, I don't know how many bytes are in this stream, I'm just, reading it. By the time you're writing the body, you should have already written the header that says the length.
Yes.
So you have to consume the whole stream in order to figure out how many bytes you're going to send.
Which is
so you can put that in the header.
I mean, it's fine if you're serving static content off of a disk where you're like streaming it from disk and you can go, how long is this file? And it's immutable. It's not going to change on me. Okay, it's 2 terabytes. Cool. Content length, 2 terabytes. Here it comes. But yeah, if it's being streamed by a process for some reason, it's like outputting, you're catting a file or whatever, something ungodly. Don't do this.
Or another socket that you're reading from, right? Like you're trying to act as a proxy, perhaps.
Then you don't know ahead of time how long the thing is going to be to write it into the header, because you've already sent it. And anyone who's written web server software has almost certainly had some kind of exception thrown when they've tried to do something silly in the body handler, where it's like, no, you can't do that because the header has already been sent. Like this is, I forget, I've definitely hit it with, crikey, I can't think of the name. But in some cases where you're trying to do something, it's like, no, look, I've already sent the header. I can't now mutate this. I can't turn it into a streaming request. I can't turn it into a different sized request because we've committed. We're done now. You just have to send text now. Sorry about that. There is multi-part though, which is a pretty crazy hack.
Right. Multi-part uploads. If you've ever used like an object store that supports HTTP, like Amazon S3 and other ones like this, you wind up sometimes doing multi-part uploads because otherwise, if you have a lot of data to upload and something goes wrong on the 99th percentile byte of your 5 terabyte file, you got to do it all over again, which is very inconvenient. I think there might also be, for S3, now that I say it out loud, there might also be another portion of the S3 protocol that allows you to
I was going to say, I think those are separable, because certainly S3 lets you configure, like, where do the slices of a multi-part upload go? And how long do they live before I delete them away?
Right,
but then there's multi-part, which is more like, you say, it's almost like a streaming protocol where you say, hey, I'm going to keep sending you data. Here is the delimiter. And you come up with some string that you hope to God doesn't appear in your actual data.
Right.
And then you say, this is the thing that tells us that we've done this chunk and we're going to give you some more headers, I think. I think that's how that works. Now, I'm very much in dodgy territory here. I've looked at it with WebSockets before. There's some kind of thing that you have to do to get it to, during the handshake, at least of WebSockets as they were in the 2010s. So 15 years ago.
Okay, so exploring other areas where you might do this, and we've explained this simple model of the world. We're sending text or receiving text, everything's fine, and you sit down with Telnet, and you're like, I'm going to do what Ben and Matt said.
We didn't see. So the curl, for example, or if you tell it directly, you will see the headers of the response, but curl was hiding them from me because I just did curl the end. So typically you'll see something along the line of, first of all, something that says 200 OK.
Yep. Yeah. There you go.
The response thing that says like your get verb and whatever, you get a response document that starts with what was the code? And we all have seen the codes. The 2XX ones are like everything's fine, and they have slightly different flavors. But usually 200 OK is one that you'll see. I think there's one of the 2XX ones is like okay, but no data, is like just yes, this is fine, but there's nothing to come, which you see on very occasionally. 3XX ones are like exceptional case type stuff. Is that right? What is the definition of 3XX? Because they're like moved and stuff like that, isn't it?
Like there's temporarily moved, permanently moved. I mean, it's most of the. I think all the redirects are in 300. There might be other things in 300.
That's the kind of edge casey thing where there might be, and then certainly 400. 4XXs are errors of sorts, and like
the world famous 404, which you probably know if you're not a programmer. But there's the one that Twitter proposed, and I think actually got introduced to the standard, 420 enhance your comm for rate limiting responses, which is a reference to the movie Demolition Man.
That's cool. I know there's I'm a Teapot is one of the things which you do, which is an error code that a tea machine may return if it is asked to serve coffee or something like that.
Exactly.
And then obviously if something breaks in the server itself and the server wants to let you know that something hideous went wrong internally, it'll give you a 5XX. What are the 10XX things? Are those like continuations, I think, for stuff like multi-part? Oh, no. See, I'm trying to do this without Googling because I have the loudest mechanical keyboard. So everything you're hearing, dear listener, is coming off the top of our heads and possibly other parts of our anatomy, depending on how accurate they are.
That's right.
So, anyway, exactly and then after that, you get a sequence, of headers that look like the ones that you sent up. So it's, something : something else. And then there'll be 2 new lines, and then off you go with the data, the response. So that's it's pretty cool. It is. And
so this is perfect. Actually, this is a perfect segue. So coming back to what I was saying before about like, okay, I'm going to do what Ben and Matt said. I'm going to sit down and I'm going to like type these things out in Telnet, and I'm going to get back some response. And when I do that, all I see is a bunch of gobbledygook. I don't see any text. I don't see any HTML. What is going on? One of the things that might be going on is that the server has compressed the response, and it will tell you that it has done that, and it will tell you which compression algorithm it has used to do that in the headers. So you'll see a compression header, and then you will see
the header will be the text-based headers are still there.
Yes.
Just to be clear, right? And then there'll be a new line, and then you'll see garbage. Which, although a well-configured server ought not to do that unless you said I would accept a compressed thing. But nevertheless, this is exactly the kind of thing, to your point at the beginning of this, is like when something goes wrong,
right?
I'm getting an endpoint that just assumes every client can support a compression algorithm,
right?
Which I believe you're about to go and talk about. So I don't want to keep. I don't know.
Well, yeah, no, and that's another thing that curl is, again, peeling back the abstraction here. That's another thing that curl is doing for you, right? It's reading that header, it's applying the correct compression. I think you might need to tell it. I can't remember if you just can you disable it? Can you tell it not to do that?
I don't remember either. I know I've had problems before because, and this is going to lead to one of my favorite observations, or rather of a mutual friend's observation, whether it's transparently decompressing because it says it's deflated, and so curl is then going to say, well, I'll undeflate it then because that's what it says that I should do. Or whether that just means the fact that the compression is, whether the compression is there or not, is now opaque to you. You don't know if it's happening or not, which is the kind of dichotomy of transparency means that now it's impossible to see whether it's actually happening or not. Our friend coined the term, which I introduced somebody to at work yesterday, transpake, which is like that kind of combination of like, well, it's like you're meant to not know it's there. But if it is there, now you can't tell if it's there or not, and maybe it's broken, and now you're just being gaslit by your system, right? I think we had this with at least one of the things at work where a vendor was sending gzipped data, but whatever accept header we were getting was then un-gzipping it for us, even though we'd asked for, like get bob.gz or get, this day.gz. And then the library was like, oh, cool, I'll un-gzip that for you. And then it was storing it as, and we were writing it to disk as, bob.gz. And you're like, why is everything so huge? Oh, wait, everything's called .gz because that's what we asked for, but something transparently, again, transpakely, un-gzipped it for us, being helpful, thinking it was being helpful, and it wasn't. Right. Anyway, but yes, it could be deflate compressed. I think, or what are the other ones that are out there? The Z standard, I think, is that standardized? I don't know, but deflate's the one that everyone uses, which is to say gzip. Pretty much to a first approximation, deflate is the algorithm that powers gzip, and then there's a little tiny bit of a header associated with an actual gzip file, which I think is slightly different, and a CRC. So that's definitely something that can go wrong.
Yeah. Do we want to try to get into TLS and compression and HTTPS? Is that a bridge too far for this conversation?
That might be a bridge too far. I don't know enough about it. So what we've been talking about so far, let's graze the topic and see if we feel comfortable with this, right. And then our listener can roll their eyes at how wrong we are. But what we've been talking about is like the HTTP protocol, and in HTTPS, there's another layer, another sort of wrapping of the protocol where a certain amount of some encryption is applied and authentication and certificate exchange, all that kind of stuff. But once you've peeled that back, you're back to HTTP again. So like effectively from the point of view of the web server itself and from the web client, you can almost ignore the fact that the tunnel that connects them is an encrypted tunnel as opposed to just a regular telnet. So obviously you can't telnet to port 443 and type anything and expecting it to happen, which is unfortunate. What you can expect, what will happen is if you're very lucky, you might see a load of garbage bytes being sent back to you and then the connection is closed. That's probably what you're going to see if you do anything at all, if you telnet to port 443. Something that surprised me the other day is I naively assumed that you connect to port 443, some kind of negotiation happens with a certificate and key exchange and the whole Diffie-Hellman thing to get a unique key on both sides. And then and only then do you start saying, hi, I'd like to get this,
Right.
But,
I was going to say this exact same thing.
Yeah. But it turns out for the same reason that we added the host colon to the sort of like the message body rather than just relying on the telnet, the IP address that you're connecting to being unique for that website, we lose that if we encrypt it, which means that the web server you're talking to, if it's, google.com is co-located with yahoo.com, unlikely. But whose certificate should the server give you when you connect to it? You're like, good question. I don't know, which means that you, the client, need to tell it first.
Yes.
But how do you encrypt that so that no one can tell which site you're actually browsing? And the surprising answer is you don't.
Yep.
Which was like mind blown.
Yep. Oh, not as secure as you thought. All that information is being exposed to the interwebs.
Does this mean that all these adverts that I keep fast forwarding through about VPNs? And dear listener, do not worry. This is not about to segue into an advert for one of those. This is not our way of announcing that finally Surfshark or whatever is
sponsorship. Yeah.
No sponsorship. This is Ben and I's fun. We're not turning it into anything else. But no, but that is the one argument I can see for that, because I just assume, fine, HTTPS everything, and it's, no one need know what I'm doing, but it's, you are actually, if you cracked out Wireshark and visited a website, which maybe we should do live sometime, we need to work out a way of screen recording this or something.
Yeah.
Because that's, I think the first time you show somebody Wireshark and then you browsing or doing anything trivial on the network, is the first time the scales fall. Certainly was for me, about like, oh my gosh, look how much stuff's going on my network or on my computer. Oh golly. But anyway, so Poppins, you were going to say the same thing about this surprising, was it SNI or something?
You should be very careful about assuming that the data that is in your request, the URL, including the query parameters, the headers that you are either adding yourself or being added on your behalf by the tools that you're using, like curl, are actually secure, because they're almost certainly not in many, many cases. So when you make that request... I was thinking it was only the host that was the thing that was leaked, just purely so the correct certificate could be served back to you, but I may be wrong. So I think that so my understanding of this is that you're doing this sort of like escalation request. You're like, I'd like to escalate to this other protocol. And I would not be very confident in telling anybody that I knew for certain that in all cases it could only be these things, right?
No, it's fair.
It's one of those things where it's like, if it's important to you that information is encrypted, then you should check probably using Wireshark or something else like that.
I've just fired it up. I couldn't help myself. Oh, I need to sudo make me a sandwich, of course, because Wireshark. Yeah, okay. Given that I have to escalate, I'm not going to do that now. Otherwise, you are going to hear my long password rattling out. But no, that's definitely an exercise for the reader, and I'm sure hopefully people will comment and tell us where we're going wrong here. But again, this is from the top of our heads, so yeah, no, so. Okay, I think that's probably the most we should do on the encryption, because it's clear that we've reached the limit of our.
We've hit the layer of abstraction.
Knowledge. I mean, there's definitely some things to do with certificates and things, the little lock that you see, and a little bit about that.
To know nearly enough about that to explain it to the world.
There's like a chain of trust, isn't there? We can probably talk a little about that.
Yeah, that's true.
Where
certificate authorities.
Yeah, so the browser and curl or whatever, and your operating system may provide a list of certificate authorities, which are like trusted third parties that have said, we will sign other people's certificate to say it's definitely them. Trust me, bro. And then as long as you trust the person who signed the certificate, you can trust Google.com is in fact Google.com because it's signed by Veritrust or whoever the heck actually signs Google's. Google probably are a CA, aren't they? Probably.
Yeah, probably at this point.
And that's kind of how you know that you are actually talking to the correct site, the authentication part of HTTPS. And no is got air quotes here because obviously it really does depend how much you trust the people who sign these certificates to say it really is who they say that it is. And if you look at the number of CAs that there are inside your browser, if you go and look at the list of them, there's like a bewildering number of them, including some from to me, things that would raise an eyebrow. And I'm like, oh, apparently we trust this company. I don't know who they are, and it doesn't look very trustworthy to me.
Right.
Similarly, in a corporate environment, you might discover reasonably your own company's root CA is in that list, because then you can sign, first of all, you can sign all of your internal applications with your own certificate that doesn't have to go out to the outside world, doesn't have to be signed by VeriSign. It means that you can go to, Ben's cool app.internal.com and you can get a certificate for that, and your browser won't go, wait a second, this is just self-signed. That's no good. It can be signed by, benscoolcompany.com, which is then in there. But it also allows potential for security scanning software to decrypt by man-in-the-middling you in your own on your own network to be able to check that things aren't going outside, which is really important certainly in a large corporate environment. I don't know that it happens in any
that's definitely a thing. I mean, again, the theme of this being breaking people's expectations around abstractions and things like that. It's probably been told to you in indirect ways by people at your company if they're doing this, but maybe not in as direct ways as we're reading your personal email if you check your personal email at work, right? Like the little security lock in the browser that you're running
is not as strong as you think it is, because if you're using your company, I mean, obviously if you're on your personal device on the guest Wi-Fi of your company or whatever, fine. And that's a very good reason to do that, right? But yes, if you are, most companies have at least a clause that says something like there's no expectation of privacy, which is reasonable, right? You're at work, you're doing work things.
Yeah.
Reasonable people could have disagreements about this. I get it.
Yeah.
But that is the way in which they can potentially look at the encrypted data, is that they can say, well, any website you go and get, if you go to, secure.com, I will say, yes, sure, I'm secure.com, and I can prove I am because I'm signed by this certificate, which, by the way, your company given security system says I can sign anything I damn well like, and that's fine. And that's, just knowing that exists is all you need to do. And it's an exercise to the listener to go and see whether that's something that's happening to them or not. And I mean, it's a fairly standard thing. Anyway, popping the stack all the way back, right? So we said, what about curl, right? You said curling this endpoint. What else? Is there anything we've missed? Let's just think about this.
Well, I got a good one.
Okay.
So let's say that what you see, would you do this request, and maybe you're trying to drop down a level here, and you're going to use the telnet approach, is that the you connect to the site, you type in your headers, you get back your response headers, and then you get some of the body, and then it stops.
Yeah.
What happened? What is happening? Like, how do you even know that it's not done? What is the mechanism for that? If I recall correctly, it's like 2 new lines is the fancy technology
I think
that
that's
they
the
use
hardcore thing
to tell you that the body of the document is complete. Is that we're going to do a new line and then we're going to do another new line, and that's how you know that it's done. But let's say that you don't see those 2 new lines and it just stops.
Right.
What is curl doing in that situation?
That's an excellent question. I don't actually know the answer to that. Yeah, I don't know, because like my instinct, if this was an interview question and you, Ben Rady, were asking me what's going on here, I would be like, oh, this sounds like the remote end has decided to keep the connection open, but it has in fact finished the document. And I don't know if it puts something at the end of that. I don't think it does. Maybe that's one of those 100 continue is like one of those things as it puts it in. I don't know, but
I think you could get something like that. Yeah.
But totally separately, and just pause there. I did in fact just turn it to google.com and do get space / enter, and it doesn't even tell me that I'm at the wrong address, because it doesn't know that I came to the wrong address. So it doesn't try and redirect me. It just gives me the whole, minimized google.com thing pukes out. So it still works with even HTTP 0.9. Okay. What happened then, Ben? Tell me the answer. What was going on with my home connection?
So this could be a number of things, but one scenario in which you would see this is that there was like an error, like a programming error on the server side, where it like read a document and encountered an error, and for whatever reason didn't close the connection. Right? Maybe it's waiting for data to show up that just isn't showing up. It's not
going to come up, or it's like with itself for trying to do something.
Stuck on some database query or streaming some data from another source or whatever it might be, and it's just stopped. Curl has a number of different timeouts that you can configure, and part of the reason for those timeouts is situations like this, because you don't want some process to just be stuck forever because it made some request that is now stuck forever. It has a connection timeout, which is more of a TCP level thing. It is a TCP level thing. It's like, hey, I want to connect to this IP address and send it some text so I can get my documents. If it never establishes the TCP connection, or it might take some time to establish the TCP connection, there's a timeout that you can control for that. Mm-hmm. I believe there is also a response timeout to say, like, if I start getting data and then I stop getting data, just whacked my microphone.
That's fine. I'm sure that will be edited away. It won't be edited away.
And you stop getting data, and then you continue to not get any data. How long should I wait before I just give up? And it's important to know, like with all of these protocols, we think of them as almost like you use it often enough. You almost think of it as being like this synchronous thing, right? Like almost like an atomic thing, where it's like, I'm going to do the request, I'm going to get the response, and it all works. And it is entirely possible that you get some, but not all of the response. It is entirely possible that you get halfway through sending the request and then the connection just dies. It's entirely possible that you start sending the request, and depending on exactly what is happening on your network, it may not be clear how much of it was actually sent. Like, I'm doing this like put request or delete request, right? Like, did you actually delete it on the other side?
Right.
I'm not sure.
That is, the sort of like, what's the name of it? The Byzantine generals problem or whatever. Where you like I send a thing to you that says, did you delete it? And you go, like, I got back, but I didn't hear your response. You're like, well, did you then? I don't know because I didn't act. And like there's any number of acts on both sides that you can never be 100% sure. And
Exactly. So that is definitely another place where this sort of abstraction can break down, where it's like, well, I did the delete request and it failed. So clearly it's not deleted.
5 different timeouts. I've just been looking through the man page of curl. 5 different timeouts for different conditions. Like how often, how long do you wait before a connection? As you said, overall timeout for the entire request, the first response, and then subsequent chunks of data. That kind of feel about it, and then some other things to do with IPv4 and IPv6 if you're trying to do both at the same time and get the first one to respond. Kind of feel so like some really clever things like that. And a lot of these things are sort of, as you say, we think of these things as atomic. We think about, everyone talks about RESTful APIs, and you're like, okay, it's like a magic RPC that I just do, and it happens or it doesn't happen, and I'm done. And you're like, no, you could see an error on your side that says the connection never got the request never went through, but it did in fact make it through. It was just the response didn't get to you, and the TCP was torn down, but it did in fact take effect on the remote end, and now you're stuck. You didn't get back, the thing the response. So
Absolutely.
It's a tricky world out there, but yeah. No, there's many timeouts. Oh my gosh!
You said there's 5 timeouts?
I think so. I've got connect timeout, expect 100 timeout. So maximum time in seconds you wait for curl for a 100 continue. Oh, good. I wasn't completely making that up. See also connect timeout. Happy eyeballs timeout. That's hilarious to me.
Happy eyeballs?
Yeah. Timeout? I'm going to read this to you because it's joyous. Happy eyeballs with a capital H and a capital E is an algorithm that attempts to connect to both IPv4 and IPv6 addresses for dual stack hosts, giving IPv4 v6 a head start of the specified number of milliseconds. So it's like a way of, preferring IPv6, but not necessarily.
Oh man.
So good. Yeah, we've got see also max timeout, retry max time. So there's an overall max time. And then there's a retry maximum time, which is like the number of times, including, retail time is reset before the first friend. It's complicated, but
yeah, and we're back.
Because what happened there was a terrible break in the abstraction layer because my USB hub crashed and put us into a very bad state, and we've just about recovered it. And I can't remember what on earth we were talking about.
No idea at all. It's like it was a different dimension.
And if only we had some kind of permanent record of what we'd said. But sadly, neither you nor you said you could download the MP3s, okay, and it was working. So at least we've got that on our side.
Did do that.
Okay,
yes.
Right. So we've got the previous part. So, dear listener, we apologize. Whatever we were talking about before has slipped our minds. But we didn't want to leave you in the lurch, or more importantly, we didn't want to leave editing Matt with a job of like, how do you finish an episode where clearly something went wrong? But I think there's another abstraction layer. We can talk about that another time. It's like how on earth our devices talk to each other in a sort of day-to-day environment.
USB actually would be kind of like
USB,
cool one.
USB-C and DVI and
ambitious,
video and like all those kind of magic. I mean, it's a miracle that it works as well as it does, frankly.
Yeah.
But yeah, we were looking at curl, and I think we were just about to look through all the timeouts. That's what I'd recall.
Talking about the happy eyeballs?
Happy eyeballs for IPv6, IPv4, which is crazy. I saw someone had put an IPv8 proposal out there, which I think is somewhat tongue-in-cheek, but also I read through it and I was like, this isn't as stupid as it looks. Maybe this is real. I can't tell.
And they skipped 7 because we skipped 5?
I guess. I think it uses like a 64-bit IP address rather than the full crazy IPv6, I don't know, 256-bit, 128, whatever bit size it is, where it's like, hey, all this information about the host, like, I don't want to leak that outside my network. Thank you very much, right? Yeah. So it was and it's sort of backwards compatible with IPv4 because it's essentially all existing IPv4s are 0.0.0.0. the rest. You're like, oh,
interesting.
That makes sense. Maybe that's got legs. Anyway, that's really off topic, and that's about as much as I know about it. My friend, I don't know if there's anything that we can recover from where we were going. So I think we should probably just call it at this point here. And having introduced the world to transpacity, I feel like we've at least achieved something.
Transpacity. Okay.
I guess it would be, wouldn't it? Yeah.
Yes, it is. That's exactly
transpacity. We'll have to ask our friend and see if maybe he'll join us on the podcast sometime to talk about it. But it's definitely a thing. All right, mate. Well, it's been a journey today.
Fun times.
I will chat to you another time.
Sounds good.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcript and notes at www.twoscomplement.org. Contact us on Mastodon. We are at twoscomplement@hachyderm.io. Our theme music is by Inverse Phase. Find out more at inversephase.com.